And now, for a session produced by our underwriter, please welcome John Paul Clarke, Vice President of Strategic Technologies at United Technologies Corporation.
So now for something a little different. We've been talking a lot about ground infrastructure, and we're going to be talking for the rest of the session this morning about moving stuff and things that move. And with that said, I have a few remarks I thought I would make to sort of set the stage for the last part of this morning. I'm academic at heart, so I'll start with the literature. So the economic development literature, such as the work by Mellinger and Jeffrey Sachs and Gallup, suggests that temperature ecozones, or temperate ecozones, within 100 kilometers of oceans or ocean navigable waterways are 18 times more likely to have a higher GDP than those that are not. And if you look at the facts, this correlation is in part due to the fact that for centuries, only communities near waterways or near the ocean were able to trade. And this, of course, is before the advent of the locomotive and then the automobile and the aircraft. So if trade is indeed a necessary, albeit not a sufficient condition for economic development, then infrastructure and the transportation networks enabling global trade must, of course, be safe, inexpensive, and last but not least, sustainable. Safety and cost have always been an important part of transportation. New infrastructure in transportation must be safe relative to whatever societal expectations were in place at the time they were introduced. Of course, our expectations change. They usually go up. But at the time of introduction, we have to be safe relative to the expectations. And of course, it has to be inexpensive relative to how much our customers are willing to pay. Sustainability, both economic and environmental sustainability, have become a priority over the time due to diminishing availability of and access to raw materials. We all know that story. And the threat of climate change, which has been the subject of discussion today. So given safety as a fixed constraint, our objective must be to simultaneously increase the economic and environmental efficiency of transportation. And I use that phrase, economic and environmental efficiency, deliberately. i.e., we must strive to do more with less. I'll limit the remainder of my remarks to air transportation, because I decided to play it safe today and speak about something that I actually know something about. Moving billions of people around the world every year requires billions of gallons of fuel. 17.5 billion alone in 2017. In fact, the International Air Transportation Association projects that in 2018, the bill would be around $206 billion, accounting for 25% of the operating costs of the airline industry. It's estimated the aviation industry contributes 2 to 3% of the world's human-generated carbon emissions and 12% of CO2 emissions from all transportation sources. Further, aircraft noise continues to be an issue with communities around the world. I don't need to tell anybody that one. To achieve greater economic and environmental efficiency, we need, at the very least, to answer the following 3 questions. How can we best use technology and autonomous solutions to enhance safety while at the same time increasing collaboration and optimizing workload? How can we take advantage of all the data being generated? We talk about Internet of Things and all these sensors around the world, generated across the economic aviation ecosystem to unlock new insights that deliver efficiencies for operators and more seamless and rewarding travel experiences for passengers. That's the self-interest part for me. And how can we reduce aviation's carbon footprint, noise pollution, operating, and maintenance costs? The short answer to these questions is more. More sensors, more intelligent aircraft, airline, airport, and air traffic control systems, a more connected ecosystem where human and machine agents team up, collaborate, and coordinate decision-making to achieve greater efficiencies overall, more electrification of aircraft and propulsion systems, more use of alternative propulsion architectures and fuels. How could all this sensing, intelligence, connectivity, electrification, and use of alternative architectures and fuels help us? Let's consider this all too familiar scenario, at least for me. It's a late night, and you're on a flight from New York to Denver, the last flight of the evening. The Northeast Corridor is experiencing departure delays because it's congested, and Denver is expecting snow. 30 minutes after its scheduled wheels-up time, the flight finally takes off, leaving Manhattan behind. Soon after, the pilot comes on the intercom and says, "Hi, folks. Sorry about the delay getting you off the ground, but good news, I've gotten permission from operations to fly at a faster speed, and I can recover most, if not all of the time, so that we can have an on-time arrival." Passengers settle back in their seats, relatively confident that all is well, until the plane lands. It turns out Denver's snow was worse than expected, resulting in a ton of departure delays, and everybody had to return to the gates. So as the flight taxis to the terminal, it becomes clear that there's no gates for your airplane. And it will take an half an hour until one will be open. In these scenarios, passengers have gone from unhappy to really happy to unhappy again. And we burnt a ton of fuel along the way, all for no gain in time. So let's imagine an alternative scenario, a parallel universe, if you will. I have 12-year-old twins, and they live in the parallel Marvel universes all the time, so this is very good. So let us assume that there's ubiquitous sensing, precise positioning, navigation, and timing, increasingly autonomous intelligent machine systems, and a highly interconnected and secure communication network. Given these combined capabilities, which I and many others believe are possible in the near to medium term, the pilots, dispatchers, and air traffic controllers would have had high confidence forecasts of the weather and the impact of the weather on the availability of airline, airport, and airspace resources, be able to precisely predict, monitor, and control the movement of aircraft in collaboration with autonomous and highly automated systems, and thereby have the means to both predict and optimize the traffic levels throughout the air transportation system, i.e., you'd have an extra time in the lounge before you departed. You'd be boarding just about the right time, but when you arrive, you would never have a holdout, which is the term for getting there and not having a gate. So, in a connected ecosystem, every agent, whether human or machine, will have the data that's required to gain insights and be able to collaborate with other agents to achieve greater system-wide optimality. So, again, you don't have to wait on the ramp. And everything will be adjusted, and you'd actually have a flight path that would not require airborne holding, which is the worst thing ever, at least for me. So the economic and environmental benefits of what I've talked about before could be further amplified when combined with revolutionary new technologies such as the geared turbofan, which we built. Why I'm saying it's further amplified. Well, you're going to get the efficiency from better operations, but if you have a basic thing that you're operating that's more efficient, then you get a double benefit. And so, like the geared turbofan, you can reduce the noise footprint relative to the previous engines by 75%, decrease fuel burn by 16%, and reduce regulated emissions by more than 50%. Further benefits we predict will be obtained through advanced materials like CMCs, or ceramic matrix composites, which compared to traditional materials allow you to increase the temperatures in your hot section of your engine, which means more efficiency. The utilization of parallel hybrid electric architectures are also on the horizon. This is a great tie-in with the conversations we've had before on ground infrastructure. Of course, the challenge being battery density and energy density, but we're working on that. Electrification will provide benefits over a wide range of segments. At the low end, in size, urban air mobility, you can get all electric airplanes. In the middle range, regional turboprops, you can get airplanes where 50% of the power is being supplied by electrification. At the higher end, it's a little bit more challenging because of the energy density. So you'll probably get partially hybrid. However, that will allow you to optimize the systems better and gain efficiency both in terms of electrification and also in terms of the design of your engine. In fact, some of the studies that we've done suggest that with certain architectures, aircraft engine architectures, and certain missions, you could reduce fuel burn by up to 40% through hybrid electric systems, and carbon dioxide emissions by over 20%. Further, and this is really cool, electrification can allow you to integrate your engines and all your systems in the airplane. So you can actually trade how you use the energy between propulsion and managing the energy on board the aircraft. For example, climate control systems, etc., pneumatic systems. That said, we will ultimately need a portfolio of technologies and industrial proficiencies to achieve these critical economic and environmental efficiencies. With these larger technological advancements, while these are basically larger, longer-term things, because it takes a while to build the stuff and get in the fleet, we must not forget that we can start today. As committed to at this year's past Paris Air Show by the CTOs of the largest 7 aerospace manufacturers, we as an industry are committed to both improving technology, but also to using alternative fuels in the short term. While electric-powered aircrafts are in our future, we also know that aircraft industry will require reliance on liquid fuels for decades to come. Knowing that, we need to have alternative fuels as part of our portfolio of technologies and solutions. Around 185,000 commercial flights have already been flown using alternative fuels, and basically our goal is to create fuels that can be recycled. When we achieve the scale that we need, we as an industry will have the near-term and long-term scope to succeed in getting this mission, critical mission of economic and environmental efficiencies. Thank you.